All right, so we finally reached chapter 7, and that means we're ready for what I consider the most important lesson in the entire course. The thing is, it's not really just chapter 7. This covers a lot of stuff, which is why I consider it the most important part of the course. All right? So I call this lesson the 6 Shapes of Algebra, and the lesson we learn from each one. So, depending on how you count, there are 6 shapes in algebra, and each one is there to teach us a lesson. Now, I could just jump into that lesson, but I'd be doing us a disservice, because the reason why I consider this the most important lesson in the course is it's one of those moments where we drift away from what I call flashcard moments and we go into fluency. So I have these covered up. Let me delete them one at a time here. Well, this one's not covered up. Flashcard moments I consider numbery. It's not a word, so it's underlined, but numbery. They're facts, they're calculations. Fluency is understanding. Logic, I don't know, logic I could probably have mentioned on both of these, but understanding is probably the key word. Fluency is driven just by a very simple understanding of something. And when I say something, I'm not just talking about a math class. Usually when someone says fluency, they're talking about a language. And that's exactly what I want to compare it to. I say fluency is faster than thinking. Fluency is getting a joke without someone having to explain it to you in that language. Let's say Greek. If someone told a joke in Greek, I wouldn't get it. Someone would have to explain it to me. Fluency is long-term, and it spans multiple courses. And a lot of math is intended to do this. If you look at the education code or something, they'll say, this is what everyone should learn in first grade, second grade, third grade. And I'll give you a quick example of that. First grade students learn to skip count. 2, 4, 6, 8, 10. You're counting by twos. 5, 10, 20, 30, 40. You're counting by fives. That is, number facts and calculations, patterns maybe. But it eventually becomes a full understanding of the multiplication table. A full understanding of the multiplication table. Fully understanding it without having to count on your fingers or something, or skip count, would be, one of the first examples of fluency we all experienced. But let's go over what we're doing. Flashcard moments. So, flashcard moments, I wrote this verbs and spelling. It would be like if you took an English class called verbs, or an English class called spelling. Those would be flashcard moments. They're not really helping your fluency. I mean, you're learning something, but is it fluency? Well, the answer is certainly no. I mean, I'm saying in an actual language class. If you ever did take a language class, they probably won't really spend a lot of time on verbs and spelling. And that's another issue, and that is time. Flashcard moments are what happen in a short amount of time. Fluency is long-term. I wrote 5 weeks here. We're in a 5-week class. What did I say here? Yeah, almost all homework problems are flashcard moments. This class maybe even more so because I use the homework questions as a test bank. But it'd be really hard to test your fluency, and you're going to find out now, right? Because we're going to have a lecture essentially on fluency a little bit. You're going to find out how This is very hard to test. But if you do go into math classes, and even if you've taken other math classes, a lot of times I'll put proofs here. A lot of times the way a math course tries to test your fluency is to emphasize proofs. And the more, higher math classes you take, the more proofs are emphasized as what I consider a fluency, a logic and understanding, rather than just doing homework problems. But just want to let you know where we are, and we are not, on this page of fluency. The way I say it now is I'm going to talk about fluency in this most important lesson of the course, but fluency doesn't put points in your test in this class. And if you take another math class, probably in that class as well. What puts points in your test are these flashcard moments, just because that's where we are in the whole learning process. But I don't want to leave out the idea of fluency in at least one lesson. So here it is. I call this the 6 Shapes of Algebra, and let me say a few things. A lot of this is my own take on things. So I'll call it a Henschelism. Don't go to your next instructor and say, hey, what are the 6 shapes of algebra again? I got to tell you that, no, your next instructor won't understand what that means. Just kind of something that I pieced together. And somebody else, in fact, might consider circles and ellipses to be the same shape, because technically they are, but it's better for me to talk about the 6 shapes. So I'm taking a few liberties here. I don't think anybody else talks about what I call half parabolas in the same way that I talk about them. So just remember that. All right. But let's see. What am I saying about this 6 shapes of algebra? I mean, I really do think there are 6 shapes, just that I'm saying the rest of the world doesn't speak this way. As children, we learn the shapes of letters, both capital and lowercase. Plus, we learn several geometric shapes, circle, square, rectangle, etc. In the same manner, there are 6 shapes in algebra that you have to know. And let's start off with a few things. I say in the same manner. No, not at all. When you were 4, 5, and 6, learning the letters of the alphabet, I wasn't there, but I can guarantee you had trouble with letters like B and D. A lot of 4, 5, and 6-year-olds already understand that those are the same those are the same shape. And it's just enough times they were told, no, those are different letters. Children want them to be the same shape. And I'm saying that they are the same shape. Okay, you might have been told to do a little style change to the letter to distinguish it, but they're the same shape. And we're not done. P, and if I draw it a certain way, Q might also be the same shape. And like I said, I wasn't there, but children have very hard time with these letters because adults are telling them they're different, but their minds is telling them they're the same. One fix is to draw some lines on the page, and suddenly where something fits in the lines becomes an important part of its meaning, kind of like today's lesson, because we're going to talk about changing the location, changing the orientation, but not changing the shape. I'm going to go ahead and add, almost everybody, even adults, understand that 6 and 9 are the same shape, just kind of different orientations of the same number. And yeah, it kind of fits in that line right there. But, you can convince a 6-year-old that 6 is different than B because of the curve or something. So this is a different shape, but all these are the same shape. And if you're not with me on that, I need you to be with me on that. All right, those letters are the same shape. And so it's a different manner than you learn the letters of the alphabet. I want you to be aware of shapes. One thing that actually, this is kind of happens in a geometry class, the unfortunate coincidence that the letter C looks the same whether it's capital or lowercase. What's that middle one? Is that a lowercase c? Is it a capital C? Yeah, I don't know either, because the only difference between the letter C is its size. We're kind of going to touch on that too, but this whole thing you went through very early in your life, I want to tap into that skill that you must have developed and talk about, like I said, the 6 shapes of algebra. All right. So you might not see the connection yet, but I'm hoping you will. So what are the 6 shapes? Lines, half parabolas. Again, I'm the only person who calls them that, but you'll understand what I'm talking about when we get there. Circles. That says x minus h squared plus y minus k squared equals r squared. Ellipses. X squared over a squared, y squared over b squared equals 1. Now, you might have seen ellipses in another course. You've certainly seen the first 3 in this course and maybe in other courses. You may or may not have seen ellipses, hyperbolas. I think we just touched on exponential and logarithms. But these two are covered in chapter 7, which is where we are. Like, this is kind of a pre-chapter 7 lesson. But these are the shapes of algebra. That's it. There are only 6 shapes in algebra. Trigonometry adds 3 more shapes: the sine and cosine wave, the tangent shape, secant, cosecant. We're not studying those, but just thought I'd let you know that. Inverse functions do not change the shape. So, again, I mentioned something from trig, which is kind of the same level as this class. Inverse sine is the same shape as sine. It's not a different shape. The orientation might change. Yeah. So our book started off on what I think was kind of a bad foot. Our textbook gave us a library of basic shapes in chapter 2. I mean, every book does this. Then adds to it piece by piece in later chapters. To me, I say that's sort of like learning the alphabet one letter at a time. It's not really teaching you the whole fluency, fluid, general ideas. It's just teaching you stuff like what am I talking about? I'm talking about, they say, oh, this is x squared, and this is x cubed, and that's true. But what do you do with that? Can you connect that to something else? Or is it just one of those flashcard moments where you just learn something and hope that that same question shows up again? Well, I think we've had a lot of flashcard moments, and I'm hoping to connect it to a few other things. So we're not there yet, but in today's lesson, but we'll get there. All right. So lines are the first shape we learn. And I came up with this question that I think is kind of a question that does teach the fluency. It's a multiple choice question. And the question is, if I have these points, X, Y, and Z, which of these points lie on that same line? Now, you've had questions like this where the author gave you 3 points and you had to verify that they formed a right triangle. This was one of the homework questions. Use the distance formula, or I think it was an example that I did in one of my video lectures. and you calculate the lengths, and you run it through the Pythagorean theorem. Not my point. I mean, my point is that's very numbery. This one, I'm saying, shouldn't have to be that way. We could calculate the slope, verify that these lines lie on the same line. But if you understand lines, and the lesson is the lines are uniformly spaced, the points are uniformly spaced, and there's some pattern recognition here. So if I were to take a line and use that slope, notice how I'm keep maintaining my slope of 1/2 every time here. The rise is 1, the slope is, the run is 2, right? Slope of 1/2, and it's pretty obvious what the answer is. The answer is point B is collinear to the other points. I didn't have to draw an X and Y axis, use the slope formula. That's one of the advantages of, having a picture, but more than that, to just knowing how lines work. Now, I'm not saying there's a real problem with proving it numerically, but there's just something quick and fairly good to understand, easy to understand, when you understand how lines work. Now, this might be a surprisingly simple question, but I can tell from the answer students give in a regular, paper and pencil course that they don't get this. For example, I'll have students draw a line, and they'll draw a line and they don't care what happens after the points they plotted. I've had students drift their lines way off. Just so you understand, this isn't a magic trick. That's wrong. I didn't draw a straight line, or I didn't obey the idea that lines have slope. And if you know this, it makes a lot of things easier if you have a familiarity with a line. All right, so lines are there to teach us something about slope and about patterns and not violating those patterns. Lines. What I call the half parabola is, well, kind of obvious what it is. It's a half a parabola. There is a half parabola. Where's the other half? Well, it depends on the problem. There's a half parabola. But hold on, I could orient it this way on its side, and that's still half a parabola. And this is one of the things I was talking about earlier. I need you to see the connection. Even though I changed somehow the orientation of the graph, it's still the same shape. All right, so these four, one for each quadrant, all right, are for x squared and x cubed. And before you start saying, where's x squared and x cubed? Well, some graphs require only one of these half parabolas, and others require two half parabolas. And they're going to be, two half parabolas joined together. All right. All right, so that shape, and then these, square root of x, cube root of x, etc., would be for this shape. Both times it's the same shape because both times it's a half parabola. All right, so if that's true, I have this question. I say consider y equals the cube root of x. All right, so it's not a hard calculation. The cube root of -1 is -1. Cube root of 0, cube root of 1. I'll get these points. And what I'm saying is there is no ambiguity here. We are 100% certain what this graph will look like from here. It's either one or two half parabolas. and it's not any of these on the top because that's for polynomials. It's got to be one or two of these glued together. Well, since I have a point in quadrant 1, I know that I'm going to have that as part of this graph. Sorry, it's off the screen. And since I have this point in quadrant 3, I know I'm going to have this half parabola here. That is y equals the cube root of x. I knew that kind of before I started drawing it, and not because I previously memorized this one graph. This could have been y equals the 5th root of x or the 7th root of x, and I really would have seen it pretty much the same way because I had these points. Now let me just change the question. Let's say the table had not given us something in quadrant 3 and quadrant 1. Let's say the question had given us something in quadrants 3 and 4. In other words, I told you nothing about the graph other than it's one or two half parabolas, meaning I gave you one of these, and you knew that the graph occupied, a point in the graph occupied quadrant 1, quadrant 2, sorry, 3, and quadrant 4. Well, if I glue those together, I'd get, I'll just draw the whole thing, this. All right. What graph is that? Well, it's any graph that gives you that monomial or a radical that gives you, when you put in -1, you get -1, but when you put in +1, you get +1. And when you put in, when you put in +1, you get -1. So some of you already know, like y equals minus x squared would work. Y equals minus x to the 4th would do that. But try to memorize this or just learn one sentence. Why not learn one sentence? Why, I can tell you why it's not common to learn one sentence to cover every possible graph, and that's because we haven't entered this whole idea of fluency. What we're working on is homework, 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 and there's really no way to change that. If you sign up for an algebra class, a class that says algebra, you're there to learn algebra. This is kind of a unifying thought that I think really makes some sense. Now, I will have to warn you that in terms of precision, this is not technically a parabola anymore. Once you leave x squared or square root, it's no longer a parabola. Parabolas are very specific shapes. A parabola would have gone through, this point, 4, 2. So parabola is only for the power of 2. So these aren't really half parabolas, but I'm saying it's the same shape. So taking a few liberties here, which is one of the reasons why you probably won't see this anywhere else. All right, that is half parabolas and what they're here to teach us. Actually, haven't even got to the whole point of what they're here to teach us. What did I say? Half parabolas are here to teach us. They're not here to teach us how to graph a half parabola. That's not a lesson in itself. They're here to teach us what negative signs do. Yes. All right. So let's look at this graph. It is the square root of x. Y equals the square root of x. Y equals the square root of x is this half parabola. What's this half parabola in quadrant 2? Well, the lesson of this is what negative signs do. Negative signs change quadrants. So even if I don't know where to put the negative sign, I know that this and this graph differ by a negative sign. And it does matter where I put the negative sign. It's y equals minus x. Y equals the square root of minus x. The book already has talked about this, and they say it in a very, fact-based, kind of sterile discussion where they say, oh, a minus on the letter x reflects the graph in the y-axis because it's an even function. That might be true, but I'm saying, if you understand this well enough to know what happens when you put in 4, you go through the point 2, 4 comma 2. Well, you can't put in 4 here because it would be square root of negative 4. You get an error in your calculator. But negative 4 for x works because if you change the sign, minus negative 4, right, that would give you 2. So what happens is this one point, 4 comma 2, is in quadrant 1. But if I find one point in quadrant 2, then I know it's a quadrant 2 half parabola. Kind of done. All right. How about this one? I'm going to skip this one right now. What graph is this? Where would I put the minus sign to go from quadrant 1 to quadrant 4? It would be y equals minus the square root of x. And again, I know that because if I just did 1 point, let's put in 4. Again, if I put in 4 in this original graph, I know I get 2. But if I put in 4 here, I have the square root of 4, which is 2, but I have a minus sign on it. So 4 brings me here, that's quadrant 4. I know it's a half parabola, I'm done. This one right here is a little more involved. It's y equals minus the square root of minus x. Yeah, if you want to take this graph, the original graph in quadrant 1, and kick it into quadrant 3, by the way, that question is almost too complicated for us. If I said, here's a graph in quadrant 1, what's the equation of the graph, and move to quadrant 3, I don't think they could ask that question in our homework. We have complicated homework questions, but this one is almost too complicated unless you really embrace this idea. If you just said, well, I know minus signs change quadrants, and I want to change quadrants, once and then again, you might be able to iron this out. You might be able to figure that out. Just as important, I want the minus signs to work in such a way that all of the points on that table will will be in quadrant 3. So I can't put positive x's in here because that would take the square root of a negative number. So I can put in minus 4, minus 4. I hope you're seeing these calculations. We're putting a minus there, a negative number there, and then change its sign, square root of 4, I get 2. This will give me this. And my only question is, what quadrant is that in? It's negative 4, negative 2. It's right here. It's in quadrant 3. I already knew the shape of square root function. It's a half parabola. I just needed to know what quadrant to nail it down in. All right. So that was a lot. I don't think other graphs teach us quite this much, but I just want you to really kind of absorb that. Maybe. Here's what I'd say about all of this. It's nice to become fluent in any one topic or the whole thing. But, graphing or everything I'm going to talk about here. But it's not a requirement because we have a test bank. We know where we're going with all of this, and we know where the questions come from. But just want you to see the possible advantage of this. I know this is pretty noisy when you just look at it all right now, but just to peel back, where we started on this. there's one shape, the half parabola, and it covers an awful lot of territory. That's the main lesson here. I could go all the way back to, the way our textbook tried to do it. Hey, learn what this looks like, learn what this looks like, and never bothered telling you the connection. So obviously it works without knowing the connection, but I just want to emphasize, and this is again why I think this is the most important lesson of the entire semester, that it's nice to know the one fact, the one sentence that explains it all, the one shape that drives it all. And if you have that, you can memorize the stuff longer and things will make more sense. All right. So I guess I should say, how do you learn this kind of thing? How do you get this fluency? Well, that's a tough question. I mean, how do you get fluency in a language? You don't do it by looking at flashcards. You pass tests by looking at flashcards maybe, but you get fluency by reading the book. You get fluency by watching the videos. You get fluency by doing things that are not just spending time on homework problems. I think a lot of students have misunderstood that I overemphasize homework problems by not requiring students to watch videos, although I do stack a lot of videos in the homework, as you've noticed. But I also recommend students look at the e-text and obviously this video here. So this video is getting kind of long. I mean, the whole lesson will be probably over an hour. So I'm going to cut it into two parts. We're going to stop on this part, half parabolas, and their lesson.